Okay, so we're going to start section 7.2, trigonometric integrals. Um, we're going to continue off of what we were doing last time. So we moved on from integrals of sine and cosine. Actually, I think this is part 4. I think that's right for this. It might be part 5. Again, I will name the video correctly, ignore what's on the screen. So I'm going to move, I've changed apps that I'm using because I finally figured out how to share my screen. I'm going to be doing this in OneNote now, just because I can scroll instead of having to make new pages, and that's a little more convenient. So we have this example here. So we want to evaluate the integral tan to the 5th theta secant to the 7th theta d theta. And so you'll remember last time we separated things so that we had a secant squared floating around. And that seemed to be, the best thing to do. Here, I think the best thing to do is, but that was because, the derivative of tangent is secant squared. Here, maybe the best thing to do is to split it up. So we have a tan to the 4th theta, secant to the 6th theta, and then we have a tan theta, secant theta d theta here. And the reason being, now I can use, that one identity that tangent squared theta plus 1 is equal to secant squared theta. I can use that identity maybe to rewrite, one of these in terms of the other. So what I'm going to end up doing is letting u equal to secant theta, because I have a tan theta secant theta here. So what I'm going to do is I'm going to take this integral, I'm going to replace the tangent, do it in terms of secant. So I can use, this identity here, and tan to the 4th then. So this identity I can solve for, so let me get rid of the trig substitution because I'm not going to do it yet. So this identity I can solve for tan squared, secant squared theta minus 1. So then tan to the 4th will just be that squared. So I have secant squared theta minus 1 squared, secant to the 6th theta, tan theta, secant theta, yeah, I'm running out of room, d theta. Let me fix that because that's not good. So we have the integral, so tan to the 4th again is secant squared theta minus 1 squared, secant to the 6th theta, tan theta, secant theta, d theta. Now the idea is, like I've said before, we're going to let u equal to secant theta, because I have a secant theta here, a secant theta here, and du will then be secant theta, tan theta, d theta, which appears there. And that's why I've done that. So this is going to be equal to the integral of u squared minus 1 squared, u to the 6th, and then tan theta secant theta d theta, it's just du. Just keep going. This is the integral of u to the 4th minus 2u squared plus 1 u to the 6th du. The integral, so u to the 10 minus 2 u to the 8 plus u to the 6th du. Yep. And then when I integrate, I'm going to get u to the 11th over 11 minus 2 over 9, sorry, u to the 9 plus u to the 7 over 7 plus my integration constant. I'm going to plug back in for u, and remember we let u equal secant theta secant to the 9th theta plus 1/7 secant to the 7th theta plus my arbitrary integration constant. And that will be, my final answer. And so what we're going to do now is we're going to write down some rules that, I'm not going to write them down. I'm going to pull them up in the book again because, you can see everything on my screen here. So what I'm going to do is pull that up and we'll just go through them. And it's going to cover, integrals of this type and the type we saw in our last example. So let's pull up the book. Let's go to that view. And now we have our strategies for evaluating tan to the mx, secant n to the x, or secant to the n of x. So if you have an even power of secant, you're going to do like what we did on the first one. You're going to separate, a secant squared. And that way you can use the identity that secant squared is 1 plus tan squared. And you can now let u equal tan theta get use under the integral. Du will be secant squared theta, or secant squared x dx in this case. So that's if the power of secant is even. And if the power of tangent is odd, you will do what we did on the last one. So you will separate a secant theta or secant x tan x. You'll let u, so in that way you're going to let u equal secant x. And then you need to write tan in terms of secant using the identity tan squared x is secant squared x minus 1. So this isn't going to be a catch-all. There might be some integrals that you run into that, they don't fall into this pattern. You're going to have to deal with those as they arise. So I'm going to switch back over to the notes and we'll talk about how to deal with some of those, some of the important things you need to remember. So here we go. So we have that, and then we may need, we have a couple integration formulas here. The integral tangent x dx, and you can do this one by u substitution, but we're gonna go ahead and write down a formula for it. And we also may need this, the integral of secant x. This one is going to be a little more complicated. This is the natural log of secant x plus tangent x plus a constant. So I'm not going to go through the derivation of this one. You can check that when you take the derivative. It does work. Yeah, I think you need a trig substitution to be able to do this without just having something, that something handed to you. So I'm going to stop here, and then we will pick back up with another example of how to apply some of these, and that'll be it. So this next video will be the last one for this section. So I'm going to stop broadcasting and stop recording.